Good morning, guys. Welcome to today's class where we'll be looking at the final example on binomial theorem. In today's example, we'll be considering all the concepts we have actually considered in previous examples. We'll be considering the negative index and also the fractional index. But in this case, this example will be combining both of those principles and concepts together. So we'll be trying to see how we can, using the knowledge of combination or binomial theorem generally, to actually expand a sum of two values which has a power, which has a negative fractional power. So in this case, we'll be combining the negative and the fractional, and then we'll still be using our knowledge of combination to actually approach it. So follow me through this. Let's do this. We have 2x plus y raised to the power minus 2 over 3, and then we are asked to expand this using our knowledge of combination. Remember, the very first thing we have to do here is to regard the overall power as our total value. So we are regarding it even regardless of the fact that we should know that on no circumstance in your combination, during permutation and combination, should your n be less than r. On no circumstance should this actually occur. But because we are dealing with binomial expansion, we need to take something theoretically. We just need to apply it. It does not necessarily mean that they are particularly correct in the real world. But as far as they can suit our purpose here, they are used. So in this case, our n value is minus 2 over 3. Since that is the total power here, we have minus 2 over 3 combination 0. So we'll be taking the first 3 terms here. Then we have minus 2 over 3 combination 0. We take the first value. The first value, as remember, takes the total power, while the second value takes the power of 0. From here, we move on, go to the next one. We have minus 2 over 3, which is still the total power, combination. The first one we did was combination 0. This one now will be combination 1. Then we have the same 2x again, 2x raised to the power. Now we remove 1 from the power of 2x and we add that 1 to the power of y. So removing 1 from here, we have minus 2 over 3 minus 1, and then we have y raised to the power 1. Taking the third term that will be taken as our final term in this expansion, we have minus 2 over 3 combination 2, 2x raised to the power minus 2 over 3 minus 2, and then we'll have y raised to the power. Obviously, we'll still have more other terms that we can even solve, but then we just take our first 3 terms as a standard. Now, expanding each of these, the very first thing we need to do from our knowledge of combination, call from combination method. We call from combination, remember that we have for any n combination r, it is giving us our n factorial over n minus r factorial r factorial. So this is still the principle we'll be using here. It means for the very first one here, the very first term, we'll be having minus 2 over 3 factorial over minus 2 over 3 minus 0 factorial 0 factorial. Taking our term here, our term here will still remain 2x raised to the power minus 2 over 3. We already know that y raised to the power 0 here will give us 1. So we move on to the next term. The next term will be having minus 2 over 3 factorial over minus 2 over 3 minus 1 factorial 1 factorial. Taking our terms here, we know when we say minus 2 over 3 minus 1, we know we have a fraction as minus 5 over 3. And then we know y raised to the power 1 will still be y. And then the third term here, the third and the final term we'll be taking here, we have minus 2 over 3 factorial all over minus 2 over 3 minus 2 factorial 2 factorial. Our terms here, this will be 2x raised to the power minus, when we subtract that, we'll have minus 8 over 3, and then we'll have y squared. So that is the term. So this is what we'll be having. As our value. So the next one, from here, we can now start breaking this down, and then we know from here, we can say, if we want to break this down, we know this will give us minus 2 over 3 factorial over minus 2 over 3 factorial, then times 1. We know this will definitely cancel this out, and then we'll be left with 2x raised to the power minus 2 over 3, which is the same thing as 1 over 2x raised to the power 2 over 3. From our negative index law, we can remember that from indices. Moving on, we can break this down because we know once we make this look like our denominator, so we can say minus 2 over 3, then we subtract 1 from it, we have minus 2 over 3 minus 1. We are going to stop here. We can keep on going and saying minus 2 over 3 minus 1, minus 2 over 3 minus 2, minus 2 over 3 minus 3, and on and on and on. But we stop wherever we know it to be easier for us to cancel with the denominator. So we are stopping here, and then wherever we stop, we remember to put our factorial. Putting our factorial now, it means you have not changed anything from the original value, and this remains this. 1 factorial will give us a value of 1, and I can express 2x raised to the power minus 5 over 3 as 1 over 2x raised to the power 5 over 3. Then times y. Since my y is here, my y can easily be up here. Moving on to the third term, I know obviously this will cancel out with this. I won't have any factorial value here again. I'll do the same thing for the last term because I have minus 2 over 3. Because I know I want to cancel it with minus 2 over 3 minus 2. So I know I'll be subtracting 1 twice. Minus 2 over 3 times minus 2 over 3 minus 1. Minus 2 over 3 minus 2. And then I'll put in my factorial here to show closure. So moving on, I can say from here I'll be having, this will be what? I'll be having y squared over 2x for my knowledge of indices raised power 8 over 3. Okay, from here we can now break it down. You know, this will cancel the denominator that we have here. So we can now see we can now have this value cancelling each other, and then moving on, we can say since our values have cancelled out here, we'll be having just 1 over 2x raised to the power 2 over 3 plus, looking at this one, you know, we'll be having minus 2 over 3. We're having minus 2 over 3y all over 2x raised to the power 5 over 3. The next term, after this have cancelled and we know, then we'll have minus 2 over 3 minus 1 here will be giving us minus 5 over 3 y squared. Now this one will be left to y squared and then divided by 2 times 2x raised to the power 8 over 3. To show the other terms that we have not included in this equation. So moving on, we know from here we can easily say that this is what 2x raised to the power 2 over 3. Breaking this down, I can say this is minus 2y over 3 into brackets 2x raised to the power 5 over 3. I can say, I know minus and minus here will give me 10 over 6, 10 over 9. So we'll be having So we'll be having 10 over 9 divided by 2, which will be 10 over 18. But then we are still having our y square here, so we have 10y squared divided by 18 into brackets 2x raised to the power 8 over 3. So all what we are doing here is just basic simplification, manipulating our division and multiplication signs, and we know that what from here we can express this. We can express this as 1 over 2x all raised to the power 2 over 3 minus 2y over 3 into brackets 2x all raised to the power 5 over 3 plus, I can break this down. I know 2 in 10 here will give me 5. I can write this as 5y squared over 9 into bracket 2x raised to the power 8 over 3. I can leave my final answer like this. I can decide to introduce my knowledge of negative index law from indices and say this is 2x all raised to the power minus 2 over 3 minus 2y into brackets 2x all raised to the power minus 5 over 3 over 3. And then we have here plus 5y squared times 2x all raised to the power minus 8 over 3 over 9. So we have not changed anything here. We have just introduced our negative index, which will now take whatever value we have here up. So to take it from the denominator side to the numerator side. So that is what has happened here. Our 2x raised to power 5 over 3 comes up, but then when it comes up with the negative sign. So we have this, and then this is, you can say this is our final answer. So this is where we'll be rounding off on binomial theorem. Do well to solve more questions so as to perfect your abilities on anything concerning binomial theorem. In the next class, we'll be taking a different topic altogether. So see you next class. Have a nice day.